Hi guys, today we're going to review for the differential equation. Okay, so last Monday we kind of like finished the review for the area and the volume. I hope the video helps you to refresh your memory. So this is a differential equation, which is a kind of like a huge possibility to show up on an AP exam, I think. So I just made a problem, okay? Consider the differential equation dy over dx e to the y 3x squared minus 6x. Let y equals f of x be a particular solution to the differential equation passing through the f 1, 0. So write the equation of the line tangent at x equals 1 and use it to approximate it. B, you have to use the Euler. C, supposed to be C. C, you have to find out the second prime. So using C and the first prime, you have to find out the Taylor polynomial centered at x equals 1, and then the last one is you got to find out the particular solution. So this is kind of like a typical like AP problem. So I kind of like mixed up the calculator and the non-calculator section. So maybe at the end for part B, you might have to use a calculator. Okay, so let's try the A. So write the equation of the tangent line at x equals 1. Okay, so dy over dx, which means that this is a slope. Instantaneous rate of change, the first prime, dy over dx, right? So write the equation of the tangent line, which is a y minus y1. So we have a y minus y1 that is equals m times x minus x1. So let's just move the camera. So number one, we need a slope, right? So, and number two, we need x1. And number three, we need a y1. x1, y1, that's a given. So is it 1, 0? So slope, so this is a slope. So I'm going to plug in 1 for x and 0 for y. So e to the 0 times 3 minus 6. So which gives just negative 3. So that's the slope. So I want to plug in number 1, 2, 3. So y minus 0. So y minus 0, which is a y, negative 3 times x minus 1. So this is the equation of the tangent line at x equals 1. But then we are not done yet. We have to use it to approximate f of 1.2, which means that you got to plug in a 1.2 for x to find out f of 1.2, right? So let me plug in. So f of 1.2, which is a negative 3 times 1.2 minus 1, which is a 0.2. So which gives you negative 0.6. So we know this one is approximation at x equals 1.2. Now let's use the Euler to approximate f of 1.2. So we know the Euler. Do you have the memory of the formula of the Euler? We know the Euler. You have to draw a chart. So here is a slope, which is a e to the y times the 3x squared minus 6x. And we know the Euler, which is a new y, is a old y plus m times delta x. And we have, this mark is right next to me. Sorry about that. We have 1, 0. And then it says a 2 equal steps. So we need a 2 equal step to find out 1.2, right? So the middle step is a 1.1. So which means the delta x is a 0.1. All right. So my new y is old y 0 plus m. We already got the slope from the part A, which is a negative 3. So slope is a negative 3. So negative 3 times 0.1. So which is a negative 0.3. So that's my new y. Right? Now we're going to plug in that value to find out the slope again. So my slope is you're going to plug in negative 0.3. So e to the negative 0.3 times. You're going to plug in a 1.1, which is a 3 times 1.1 to the second power minus 6 times 1.1. So I got the approximation, which is a negative 2.2. Now my new y is my old y, negative 0.3 and plus slope negative 2.2 times delta x, which is a 0.1. So which gives you negative. So if you calculate that, that gives you negative 0.52. So again, this one is approximation f over 1.2. So now next one. So find out the second prime if it's overestimate and underestimate. So overestimate, underestimate, it is about the concavity. Okay, so let me just write down here. So if it's a concave up, which means a second prime is a greater than 0. So we know this one is a smiley face concave up. Draw the tangent line. Tangent line is a below. So which means this one is a underestimate. Okay. Now concave down, which means the second prime is less than 0. We know this one is a sad face. If you draw the tangent line is above the graph, right? So which means this one is a overestimate. So underestimate and overestimate is about the second prime. So let's find out the second prime. And then we got to plug in a 1 to see if it's a concave up or concave down at x equals 1. So since this one is a product, we got to use a product rule, first is second, second to first. So now let's try. Second prime is a first. So first, the second, so derivative of 3x squared minus 6x, which is a 6x minus 6, times the dx over dx, which is 1, plus second, the first, derivative of e to the y, isn't it just itself, e to the y, but then we're going to multiply by dy over dx, right? Now I want to simplify e to the y, 6x minus 6 plus 3x squared minus 6x times e to the y. We got to replace dy over dx is right there, right? And then you're going to substitute that for the dy over dx, which is e to the y times 3x squared minus 6x. Okay, so this is the second prime, but we are not done yet. At x equals 1, so which means that we're going to plug in a 1, 0 for x and y. So let me plug in x equals 1 and y equals 0. So if you plug in a 1 for x, this is a gone, so this is a 0. And if you plug in a 0 for y, so 1 and a 1, so which is a 1, plug in a 1, so 3 minus 6, which is a negative 3 times e to the 0, 1 times 1 times negative 3, which gives you 9. So we know 9 is a positive, so which is a concave up, right? So isn't it concave up? Now draw the tangent line, isn't it below the graph? So we know this one is a underestimate. Okay, so x equals 1. All right. So now find the second degree of the Taylor polynomials and then center at x equals 1. Use it to approximate at x equals 1.2. All right. So when you find out the Taylor or the Maclaurin polynomial, so we need a center, right? So which means that we need f of 1, f prime of 1, we need f second prime of 1. Okay. So now f of 1, we already got that from the top. It says a 1, 0, the f of x. So f of 1 is a 0. And we need f prime of 1. So we already got that. So from the part A, which is a slope, we already got that. So which means if you plug in a 1, 0 here, so we can get the negative 3. So f prime 1 is a negative 3. Now, f second prime at x equals 1, we already got that from the part C, which is a 9. So f second prime of 1 is a 9. So we know this one is a constant. This one is a coefficient of x minus 1 because the center is a 1. We know this one is a coefficient of x minus 1 to the second power. Now let's find out the g of x. G of x is a constant 0 and minus 3 times x minus 1 and plus 9 times x minus 1 to the second power. But we are not done yet. You're going to divide it by factorial. So which is a negative 3 times x minus 1 and plus 9/2 times x minus 1 to the second power. So this is a Taylor polynomial centered at x equals 1, but we are not done yet. It says use it to approximate x equals 1.2. So we can plug in a 1.2. So let me plug in 1.2. Negative 3 times 1.2 minus 1, which is a 0.2, plus 9/2 times 0.2 to the second power. So if you plug in that, if you evaluate it, that is a negative 0.42. Again, this one is also the approximation. If you compare all the value, if you use the equation of a tangent line, approximation negative 0.6, negative 0.52, this is a negative 0.42. But we are not sure yet which one is the best approximation. But at the end, we're going to find out the exact value after we find out the particular solution. Now, this is a particular solution. So remember, when you find out the particular solution, so step 1 is the separation of variable. Without separation variable, you're going to get 0. So let me just write down here. So dy over dx, which is e to the y times the 3x squared minus 6x. So separation of variable, cross multiply, match up the variable. This is a y, ey. So you can just divide each side by e to the y. And then you can multiply each side by the dx. Okay, we're not done yet. Okay, so 1 point. Now we're going to take the integral, right? So let me just take the integral. If you take the integral, we know this one is 1 over e to the y. Just make sure this is not the ln, because e to the y is not the linear. Instead, e to the 1 over e to the y, isn't it e to the negative y? So the u is a negative y, so du is a negative 1. So antiderivative of e to the negative y is a negative e to the negative y. That is equal to raise the power 3, so 3 over 3, 1, which is x to the third minus 3x squared and plus c. Now it says that it passing through 1, 0, so we can plug in 1 for x and 0 for y. So plug in 0, e to the 0, 1, so which is a negative 1. Plug in a 1, 1 minus 3, negative 2 plus c, 3, c, so we know the c is a 1. So after you find out the c, we need a c back in, right? So we have a negative e to the minus y equals x to the third minus 3x squared and plus 1. Now, before we take the ln, we have to get rid of a negative sign, so multiply everything by negative, so which is e to the negative y minus x to the third plus x to the second power minus 1, and then we're going to take the ln. So if you take the ln on each side, you can cancel out, so carry the negative y, so ln of negative x to the third plus 3x squared minus 1. So y equal to negative ln of negative x to the third and plus 3x squared minus 1. It doesn't say that find out the exact value, but let me just find out the exact value just to see, Well, we're not done yet for the part F, but I just want to find out the exact value. Which one is the best approximation? So ln of, if we plug in a 1, 1.2. So let me plug in a 1.2. So negative 1.2 to the third power plus 3 times 1.2 to the second power minus 1. So if you plug in that value into your calculator, that gives you negative 0.465. So this is the exact value. So if you compare it, which one is the best approximation? I think the Taylor polynomial, right? Centered at x equals 1. So this is the best, the approximation. So this is a typical AP problem. I kind of like a mixed up in the calculus and non-calculus section. And definitely this D, you will be given this type of problem. All right, so today's assignment, it is all about the differential equation. All right, good luck. Bye.